Hello, geometry students. Today we're going to be talking about special cases of parallelograms. So every shape we're going to talk about today is a parallelogram, but it's a parallelogram that's got some extra snaz to it. So all the things that we learned about parallelograms, the definition and the four theorems, all come into play and are true of every shape you're going to see today, plus some extra snaz. So to help, I just want to ground you in all the quadrilaterals. So quadrilaterals are four-sided shapes. We're going to be studying trapezoids and kites in the next video, but in this video, we're going to be talking about special case parallelograms. So we're going to be talking about rhombuses and rectangles and squares. So before we go any further, we have to recall all of the properties that we talked about with parallelograms. So first of all, the definition of a parallelogram is a quadrilateral with both pair of opposite sides parallel. And we know that if it's a parallelogram, both pair of opposite sides are congruent also. We know if it's a parallelogram, both pair of opposite angles are congruent. We know if it's a parallelogram, all the pairs of consecutive angles are supplementary. And we know that if it's a parallelogram, both of those diagonals will bisect each other. So all of this is going to be true about every shape we talk about today. Everything here is true of a rhombus, everything here is true of a rectangle, and everything here is true of a square, because rhombuses, rectangles, and squares are special case parallelograms, but they're still parallelograms. But now for the extra snaz for each one. A rectangle is a special type of parallelogram. The definition of a rectangle is a parallelogram with four right angles. And we have one and only one special theorem for rectangles, and that is that if it's a rectangle, if it meets this definition, a parallelogram with four right angles, then this theorem kicks in, which states that the rectangle has congruent diagonals. Remember, that's not true of a run-of-the-mill parallelogram that's slanted and one diagonal is longer than the other, but a rectangle has congruent diagonals. Now, this has, here it is formally written. If your parallelogram is a rectangle, then it means that it's a parallelogram with four right angles, and in that case, the diagonals are congruent. So that theorem has some ramifications. So here's one type of problem you could come across. So pause and solve for x. We're told it's a rectangle, so we know the diagonals are congruent. We're given an algebraic expression for each of the diagonals, and so we can set them equal and solve for x. And then we could plug in to figure out the lengths of those diagonals. Here's another type of problem you could see with rectangles. Pause and solve for x, and then press play. In this case, we're using the definition of a rectangle, which is a parallelogram with four right angles. If this DEF is a right angle, because DGFE is a rectangle, so if DEF is a right angle, then we know that these two angles must be complementary by the angle addition postulate, and so we can add them up to 90 to form our equation, and then we can solve for x. Once we have x, we could plug it in to find our angle measurements. And here's the third type of problem you could see with a rectangle. And this requires really to understand all the ramifications for if those diagonals are congruent, which only happens in the rectangle for special case parallelograms here. Let's see what happens. If we knew that SBR, so this little angle up here, if we knew that was 30, well, we know these two angles are complementary, so we know this has to be 60. But then how could we get any further? And that's where we've got to think things through. We know the diagonals are congruent because it's a rectangle, and that's the extra snaz about rectangles. But remember, it's still a parallelogram. And all parallelograms, the diagonals bisect each other. Well, if they start out congruent, they start out the same, and they cut each other in half, their halves are going to be the same. So in a rectangle, their halves are all the same, and that's not true in a run-of-the-mill parallelogram, only in a rectangle. And so notice, if these are all the same, these four little triangles are all isosceles triangles. And we remember about the isosceles triangle. If it's an isosceles triangle, the base angles will be congruent. So we can finish solving this problem. We were given that this is 30. We know these guys are complementary. 30 and 60 adds to 90. But we also know that because it's a rectangle, this is an isosceles triangle, so the base angles will both be 30. That's 30, that's 30. Oh, and then complementary, because definition of rectangle, 60. And then isosceles triangle, base angles are congruent. And then definition of a rectangle, those two angles are complementary, so that's 30. And then, oh, it's an isosceles triangle, so 30 and 30, base angles are congruent. And then you could use triangle sum, 30 plus 30 is 60, so this vertex angle has to be 120. You could use linear pair, vertical angles, or you could go into this triangle and triangle sum, 60 plus 60, and then you can solve for your missing angle. So you have many ways to get around it once you realize that you have four isosceles triangles inside every rectangle. So pause, practice on your own paper, and then press play. We're going to use the theorem that a rectangle's diagonals are congruent, but a rectangle is a parallelogram, so the diagonals bisect each other, they start out congruent, so their halves are congruent, and so four little isosceles triangles are formed, so the base angles are congruent. And the angles in the corner are complementary because it's a rectangle, and the definition states that that is a right angle. The next special type of parallelogram we're going to talk about is the rhombus. A rhombus, what is the definition? The definition is a parallelogram with four congruent sides. We have two theorems for a rhombus. The rectangle only had one special theorem. The rectangle had a definition and one theorem. The rhombus has a definition and two theorems. And both those theorems have to do with shenanigans the diagonals get up to. One of the rhombus theorems is the diagonals are perpendicular. That's not true in the rectangle. That's not true in a run-of-the-mill parallelogram, but only in the rhombus, the diagonals are perpendicular. They form right angles. Another thing that happens in the rhombus is the diagonals will bisect that corner angle, the angle at the corner. So here's the first one. If the parallelogram is a rhombus, in other words, a parallelogram with four congruent sides, we know the diagonals will be perpendicular. They'll form a right angle. And the other theorem states that if we know that the parallelogram is a rhombus, a parallelogram with four congruent sides, then the angles here will get bisected. Now, the thing you have to remember is that a rhombus is still a parallelogram, and so the opposite angles start out the same. But only in the rhombus they get bisected. Well, if they start out the same, because it's a parallelogram, and then they get bisected because it's a rhombus, then that means their halves are also going to be the same. So these guys and these guys will all be the same in a rhombus, and these guys will all be the same in a rhombus. That's the special thing about the rhombus. So pause and use these theorems to find the missing angles. Because we see that the four sides are congruent, we know it's a rhombus, and so we know our theorem that states if it's a rhombus, the diagonals are perpendicular, and so we know that angles 2 and 3 are 90 degrees. And so we know we have four little right triangles. And then we also know that the two acute angles inside of a right triangle are complementary, or you could just use triangle sum to find angle 1 is 38. And then you remember that all four of these angles will be the same because parallelogram, they start out opposite angles are congruent. In the rhombus, they get bisected, so their halves are the same. They start out the same because it's a parallelogram. They got cut in half because it's a rhombus, so their halves are the same. So angle 1 and angle 4, and these angles as well will all be congruent and equal to 38 in this example. Here's another practice problem. Pause and press play when you're done. So what if it's a rhombus and I only have one diagonal? I still know that 1, 2, 3, 4 will all have to be the same if it's a rhombus. And I also know that if it's a rhombus, I know that the 4 sides are congruent. So you could look at the isosceles triangle and solve for 1 and 3, and then know that angles 2 and 4 will be the same. And the final special type of parallelogram we're going to talk about today is a square. The definition of a square is a special parallelogram that has 4 congruent sides and 4 right angles. So notice, this definition of a square has 2 parts. The 4 congruent sides means the square is a special kind of rhombus, and the 4 90-degree angles means the square is also a special kind of rectangle. So a square is a special type of rhombus and a special type of rectangle, and so everything applies to the square. Everything that's true about parallelograms is true of a square. Everything that's true about rectangles is true of a square, because a square is a special rectangle, and everything true of rhombuses is true of a square as well. You might want to pause and take a picture of this summary slide. Pause, find X and Y, and then press play. If we know this is a square, then we know all these sides are equal to each other. And so you can set them equal and solve for your unknowns. Pause, find the missing angles, and then press play for the solution. Well, we know the square, because the square is a rectangle, we know that the diagonals are congruent. And because the square is a rhombus, we know that the corner angles get bisected. And because it's a rhombus, we know the diagonals are perpendicular. Well, if they're perpendicular and these are 4 isosceles triangles, then the base angles have to be the same. Then they each have to be 45 degrees. So here's a summary of all the shapes and all of the things that we know about it. Parallelogram summary, rhombus summary, rectangle summary, and finally the square. That's all of the above, in case you want to take a picture of the summary slide. And so I will leave you with this picture of lovely purple daisies and wish you a great day.